All right, I had some technical difficulties. My computer shut down the video. So here's part two. Um, PA is equal to 9. So that's 9 right there. BQ is equal to 16. So from here to here, BQ, that's a length of 16. We also know that PQ, that's from here to here, that's a length of 30. Okay. We have circle P, meaning P is the center of that circle. So PA is a radius. We also have circle Q, meaning Q is the center of that circle. So QB is a radius. We have right angles here and here. We'll keep that in mind. Um, find the length of the common internal tangent. In other words, find the length of AB. All right, so this is another one of those problems, kind of similar to the pulley problem, where like there's a process to it, and once you understand this process, it is a difficult process, but once you understand it, like it's kind of presented the same way every time. So similar to the pulley problem, I can create a segment that I want to. So I'm going to keep in mind that we have a right angle here, okay? I'm going to create this segment here. And this segment is going to be parallel to, in this case, AB. So these two are parallel. Well, if these two are parallel, I have a right angle here where P, where that dotted line I just made, where it intersects with PA. So we got a right angle here. The reason being these two right angles, this one right here and this one right here, these are same side interior angles. So if that's a right angle, that also has to be a right angle. They have to be supplementary. Now I'm also going to extend QB out. And when I extend QB out, these two are going to meet. Keep in mind that we have a right angle here where the radius meets the tangent line at the point of tangency. We have a right angle, which means on the other side, we also have a right angle because these two form a straight angle, which means this is also a right angle because in a quadrilateral, the four angles have to have a sum of 360, or you could say that these two right angles are same side interior angles. The bottom line is we end up with this rectangle here, A, P, and then B being another vertex and whatever that vertex is. We could name it. I'm not going to, but we could. So since it's a rectangle from here to here, that's a length of 9. That's a length of 9. So what we're trying to find is the length of AB, the length of AB. So I will actually name this. We'll name that, let's see here, AB, we'll call it C. Call that point C. So CB has a length of 9. We're trying to find the length of AB. That is the internal tangent segment. Is there anything here that has the exact same length as AB? The answer is yes. If you remember, ABCP is a rectangle and PC is congruent to AB. So if I can find the length of PC, which I'm going to, I'll call this X. From P to C, we'll call that X. If I can find that, then I will also have the length of AB, because in a rectangle, opposite sides are congruent. So what you have to do now is change your focus. We've been focusing on that rectangle for a while. I kind of want you to focus on, I'm going to outline it in red, but then I'm going to take it away in a moment too. I want you to focus on this side. I want you to focus on that segment. And I want you to focus on this segment. And what do you see there when I outline those three in red? Hopefully you see that we have a right triangle with legs of 25. 16 plus 9 is 25. A leg of x. CP has a leg of x. And then PQ, the hypotenuse, has a length of 30. So with that in mind, I'm going to say leg squared plus the other leg, which is 9 plus 16, 25 squared equals 30 squared. We subtract 25 squared from both sides, we end up with 30 squared minus 25 squared. I'm going to go to the calculator now. 30 squared minus 25 squared equals 275. So x squared equals 275. I'm going to take the square root of both sides. All right, so let's see here. I don't think 275 is a nice even square root. Let's double check. It's not. So we got to do some prime factorization with 275. I can divide it by 5 for sure. I can divide 55 by 5 for sure. So it's going to be 25 times 11. 25 times 11. So x equals the square root of 25 times 11. So this is equal to 5 root 11. That is the length of AB. It's the same thing as PC. There you go. That's a tough problem, but again, they all kind of start out the same way. You create the rectangle by drawing in the parallel segment. You then focus on the right triangle and use the Pythagorean theorem to find the missing piece. Thanks for watching. Hope you have a great day. Good luck on the homework.